Get started here. Hopefully we can get past the demo goblins you saw a little bit earlier and do something with the Xbox One. But in the meantime, I'm Gabe Frost. I am on the core media platform team in Windows. I've been at Microsoft for just about 10 years, about 15 years in the industry working on everything from core networking, TCP algorithm things, all the way up into video, network quality of service. So I have a lot of experience in this area, and I'm just so pleased to be here, and thank you for coming to the session. You guys like the keynote? A lot of fun? Cool. All right, good stuff. So we're going to talk a little bit about the fundamentals. We're going to kind of have a sort of college 101 session on audio and video, get a little recap about what we've done all the way up until this point, share with you some new things and what we've learned. Over the last year, when we've seen all of these really great applications being developed for Windows 8, what we've learned, what we've observed, and hopefully done to make things a lot better and improved and create new capabilities. So again, we're going to do a quick recap of audio and video generally, set the stage, talk about some of the new capabilities, and then really what it takes to complete the end-to-end experience for your apps that use audio or your apps that use video. Again, these are the things we've observed that some apps have had a hard time working on, so we learned some things, but we also want to share some code. As a point of style, the way that I'm going to go about this session is I'm going to show a demo of some things, hopefully. We'll get to demo this thing in a minute, but we're going to show a demo. I'm going to walk through a whole bunch of what the experience should look like, and then I take a step back and I deconstruct each of those points in code. We know that people write apps in various styles, and so I'm first going to show that deconstruction of experiences around music, completing music experiences in JavaScript, and then all of the video experiences using C#. So for those of you who have different programming styles, hopefully you'll get the most out of this session. And then we want to talk a little bit about some of the work that we've done for apps that are on Xbox One and on the corresponding app on Windows 8.1 and how those things can work together a little better in the context of audio and video. So let's get started. This is a quick overview of what the media platform looks like in Windows. We break it up into four kind of high-level engines, the way we think about them internally. There's playback and preview, which is done through the media engine. Capture from the camera or the microphones, and that's done through the capture engine. Transcoding, trimming files, so converting them from one format to the other is transcode. And lastly, streaming to devices in the home like your popular flat screen television or your AV receiver, Xbox 360, or Xbox One coming up. We call that the media sharing engine. But for those who are writing desktop applications, it's really important to know that for each of these, there's actually a COM interface that exposes all the same properties, all the same methods, everything that you can access from the higher level abstracted interfaces that are available from the video tag or the media element for when doing playback or preview, or the set of APIs that we expose in WinRT under the Windows.media namespace. And so I list them here. For example, if you've installed the latest Office 2013, one of the things that you see in the very beginning is a video that says, hey, this is Office. There's like a little truck going over mountains and things. That's actually implementing using IMF Media Engine directly. So you can QI for that interface and party in your desktop applications and get all the same performance benefits and investments that we're making continually for those higher level abstracted languages to work well. So when you're writing apps for the store, you're accessing this functionality directly through the media element, if you're styling your app using XAML, or through the audio or the video tag directly. And important to note, too, that this is all the same code paths and functionality that you get from the browser directly. So when we spend time talking about the audio or the video tag or some of the new HTML5 technologies that we've built, like media stream extensions or encrypted media extensions, so you can build plugin-free applications. There'll be another session later today that talks specifically about that in MPEG Dash, how you do all those things. So really tight integration with DirectX and all the discrete hardware for doing audio and video offloading. We handle all those things for you. You can extend the platform. In Windows 8, you had to do so writing native code. You'd go write things called Media Foundation sources or Media Foundation transforms, or syncs for that matter. And this sort of shows how that works together. And one of the things that we've done in Windows 8.1 for those Silverlight developers who are familiar with media stream sources, we've actually implemented that in WinRT now, so that applications can extend formats or do really custom streaming things inside of your app code without having to write native code. So we've done some really powerful things for you. So in terms of capabilities or scenarios, things you could do in Windows 8, you can continue to do, play protected content in a video tag or even the media element. So I already talked about sort of transcoding between different formats. You'll see there's a new app in Windows 8.1 that you download called Movie Moments. This is an example of a lot of these things brought together where you can trim your video, you can create effects, and do all those different things. Low latency modes for game and communication applications, but fundamentally, this is kind of a high-level overview. All the exciting things you'd expect to be able to do in your store applications you can still do. But we want to talk a little bit more about what is new, what you can do. So across the board, we've spent a tremendous amount of time on fundamentals, on improved quality in terms of visually what you see on the screen, better color representation, true color. Battery life across the board has been improved dramatically through really close work with all of the discrete hardware vendors that are running. So on your existing Surface machines or on all the new machines that are coming out, even further capabilities in terms of battery life and performance overall. Plug-in free, adaptive bitrate, content protection in the browser, as well as in your native applications. You saw Antoine demo as part of the keynote what we call MPEG Dash, which is an emerging standard for streaming. And we have a session a little bit later today that's going to talk specifically about that, and Netflix is going to help us communicate how great this work that we've done is and how it really moves the needle forward. For those of you who are building audio applications and doing online streaming, these are the types of apps the radio applications, Pandora, Spotify, all these different types of apps. With Windows being highly focused on optimizing for running in low power states, when you need to hit the network, when the machine's in connected standby, it's been really problematic. Historically, you've had to do some fancy footwork in order to make sure that that works well. And so we've done a bunch of work to make it really easy for those scenarios to continue work. So if you need to bring in ads or if you need to bring in different items that are coming while the machine is down in connected standby, we'll show you how to go about doing that. And again, I mentioned you can add custom formats. You can do some fancy streaming if you have different streaming protocols. We've seen things, from, like a remote desktop style application being done using these types of interfaces. So long as it's audio or video, and you're responsible for getting that content however you like, you can use sockets, you can use HTTP client, you can use your own protocol, whatever you like, and be able to parse those various different kinds of audio and video formats that are, maybe not as prominent in machines, but your customers want to be able to play that, and so we've made it easy for you to do that. Unconstrained download for large files. So again, with our focus on battery life and performance if you've gone into, for example, the Xbox Video application and wanted to download a HD movie and watch it on the plane. You notice that took quite a while because we have a leaky token bucket style of a model for giving resources to these applications so that they can download and still be, not kill your battery in the background. But it kind of stinks when you want to go really quickly and watch that movie. And so we've made it easy for you to just say, yes, I don't care about my battery right now. Download this thing full tilt as fast as possible. For those who are writing media applications on Xbox One and have corresponding apps on Windows 8.1, we've done some good work that makes it possible for users to discover that application that's running on. It actually doesn't have to be running, but that has been installed on Xbox One, launch it, and have it stream directly from the internet. So we've talked about this thing for developers called the Play To app contract. So we've modified that. We'll go into some details, but we modified that for these types of marquee streaming experiences. You can edit the metadata in the media files now rather than just view it. So if you want to build a full-blown media application that has all those capabilities that you've come to expect in like Windows Media Player and other applications in the past, you can do so. So let's switch to a demo. Now, let's take a listen to one of my favorite bands right now, Half of Infinity. Play. Can I get a little more volume? Okay, so this is the new music application. I don't have a great deal of album artwork for you to take a look at here, but one of the things that I want to show is, some of the things that we sort of expect in our applications, that I can leave the app and it still continues to play in the background. I can open up different applications. All those things work. I can use the media buttons or the system transport controls to control the application. So if I want to pause the app, I can do that. I can do it even from the lock screen, which I'll show in a moment here. I can switch to the different tracks. When I open an app that plays video, for example, I really expect my music to just stop playing in the background. So we do the right things. If you have a communication session come in, it ducks the audio so you can hear the alerts that come in. All of this. And as I switch between, the right thing happens. The video pauses when it's in the background. I can swipe over and look at the devices charm, which we now disambiguate the types of devices that are shown in here. Now we know that there are things related to media, printing, and projecting onto the screen. So when I go play, I can choose Xbox One. Again, this is the demo goblins I had earlier, which may not work, so it doesn't appear to be working, but you get the idea. So I can play my music over to my Xbox 360, which we all have in our homes now, or in the future, Xbox One. And one of the things that you see when you play, whoa, so it worked. I could even go, one of the nice things about this is that if I'm on my lock screen, so I'm listening to a music playlist and I've set my tablet down on the coffee table. You don't want to have to log back in, find that application, and pause it. So now you can, straight from the lock screen, you can go ahead and have full control. And if I have multiple applications going at the same time, you can switch between those applications and have full control, whether they're playing to your Xbox or AV receiver, or if they're playing on the local machine, all at the same time. So we talked about, I showed you a bunch of things there in this sort of very simple demo. It should all just be motherhood and apple pie. We should expect all those things to work. And so we've noticed that some apps have implemented these things in different ways, and we wanted to walk through some best practices about how to go about doing this. So in order to make sure that your application continues to play in the background, you actually have to set an attribute on the audio tag, or you can do this programmatically in JavaScript, called MS Audio Category. And we have a number of predefined categories that you can set. By default, it's Other, which means that your music will get muted when it's in the background. But if you set that it is background-capable media, it'll continue to play in the background. And Windows will automatically duck the sound when necessary and handle all of those scenarios where you have multiple concurrent applications playing audio, or if you have video and audio apps happening at the same time, or if you're just using other applications. We'll talk a little bit about foreground-only media in the context of video later, and this is important because if you want to have your app mute in the background, this gives it to you for free, but it also gives you the ability to listen to sound pressure level events so that you can pause your application if it makes sense to pause it in the background. And the little code snip that I showed before, right? This is just a very silly little example here where a user just opens up the picker, selects a file they want to play, and maybe there's a automated DJ or something in this application which goes, oh, I know that track 2 is very similar to track 1, so it just goes and fetches it for the user and builds a playlist automatically. But in this case, if the machine is idled down into connected standby, even if the app is not been suspended, the network has been brought down. And so in this case, it can't actually go do an HTTP GET on this second file, and the first music track would play, it would get to the end of that track, and it wouldn't play the next one. So how do we deal with this? You had to do some fancy footwork in Windows 8, which we won't go into because it required writing some native code, and it was unfortunate. But here's what we've done in Windows 8.1. We have introduced in Windows 8 a concept called a background downloader. But when you use the background downloader and you queue up some things you want to download, it essentially puts them on the bottom of the list from all the other applications that are the bottom of the queue, from all the other apps that are using this API saying that they want to go download things. And so there was no guarantee that your track was going to get downloaded, or whatever the file is that you wanted to download was going to happen right away. So we've introduced a concept called priority, so you can set a high priority on that. We still manage the performance and the battery life here, but fundamentally, this is a very simple thing that you should do if you are the type of application that while you're playing one track, you want to go download some other ones. It tends to be more important for audio playlists, but it works in all contexts when you're using the background downloader. The media playback controls in Windows 8 required application developers to handle all sorts of different events. There were some sets of events that came from the little transport controls that you bring up by hitting the volume key that you saw on the corner there. Listening to hardware buttons from a keyboard or from a Bluetooth headset, for example, or a Bluetooth speaker. You had to listen to all of those events separately. And this was under Windows.media.media control. So we've deprecated Windows.media.media control. It's still available. Your apps aren't going to break. You'll see a warning when you compile, so feel free to continue using it. However, servicing all of that code is expensive, and we've made it way easier by adding system media transport controls, which is one simple interface. You register for a play button event or a pause button event or a skip event, and this event will fire no matter where the button came from, whether it was on the system control or whether it was a hardware button somewhere else. So we've made it much simpler. So in order to do that, you essentially create a system media control. You express which buttons you want to light up, that you want controls on. So here, play, pause. You might have skip forward, skip back. So you express which you use, and you register for the button pressed event. In your implementation of the button pressed event, you essentially look at which button was pressed and then take action. So in this case, our previous example showed audio playing, so you just simply play the audio if you get a play button, or you pause the audio if you get pause. It's really straightforward. In the transport control that I showed, you see a thumbnail. that's up there, some artwork. By default, if you don't provide a thumbnail like I show in the bottom of this simple sample, then the app tile will be used. So if you want to provide more detail to the user about what's happening there, you can do that with a thumbnail. Here we also set, track title. You update all the metadata properties in this very simple way. So breaking it down a little bit, if you don't implement media transport controls, all you see is the volume. And this is a system volume control, and it applies everywhere. No matter what's happening in the system, the whole system volume goes up or down. If you express is play enabled, then you get the play button. And in this case, if you don't specify a particular thumbnail that you want to use here, then the app tile will be used. In this case, I'm showing the app tile of an SDK sample that I just ran. But you can get more creative and implement all of the buttons in the thumbnail and even what like the album name is or the track name. So all of these details show up there, which is really great, especially for audio scenarios where someone may have set their tablet down and right from the lock screen they want to be able to control what's happening, again, whether it's playing locally or whether it's playing over to Xbox 360, Xbox One. And if you have multiple concurrent applications that are playing, for example, if I have one going to my living room speakers and another set going to, in my headphones, I don't know who would do this, but maybe I do from time to time. But in that case, you'll actually see an arrow show up there, so you can switch between the different applications that are playing audio and have full power, full control over all of those. This is how easy it is to make your application stream to Xbox. It's just a couple of lines of code. We call this the Play 2. Just like for each of the charms that are in the flyout, there's an app contract for search. There's an app contract for share. There's an app contract for settings. There's also app contracts, plural, for the devices charm. So what you see in there are project, print, and play. And this is the app contract, Play 2, which enables devices on the network to just show up in there so that your users can go ahead and tap and stream to those. You don't have to worry about streaming the media. The OS does all of these things for you. You simply create a Play 2 manager. You listen for the source requested event, which fires when someone swipes open the charm. And then you set the Play 2 source, which is your photo, your music track, or your video track. As the Play 2 source, and that's it. And then the OS does everything from there. You get transport controls for free. So if you, for example, have a music app and or a video app for that matter, and you've already implemented the transport controls, those same transport controls now act automatically like a remote control for the device. So if you change the volume, if you pause, you seek forward, even again, just to kind of underscore, implementing the system media transport controls ties those remote streaming controls directly to that little set of controls that shows up in the corner, even when you're on the lock screen. So it makes the experience much improved for users. Just to kind of overview some of the changes for the devices charm, we've disambiguated the types of devices that showed in there. In Windows 8, all the devices were just stacked up, and it was a little unclear what kinds of devices users would expect to show up in there. So we wanted to clear that up, and we provided some categories to sort of bundle those devices under. If you have a device that has NFC, you'll also see tap and send in the devices charm. If you don't have devices paired yet, you can add a device directly from the charm, so it keeps you in context to what it is that you're doing. You don't have to go hunt around and figure out what's happening with your device if it already hadn't been paired automatically, which does happen. Adobe Flash from the browser now works. So in addition to applications, for free websites are opted in. So if you go to any HTML5 based website, then you can users can swipe over the devices charm and stream that automatically. And in this time, we've worked really closely with Adobe to enable Adobe Flash content, both video and audio. So the long tail of videos and music in the browser will work with these devices. One small thing, but quite interesting, is the ability, if you have a video, but you only have an audio-capable device, to be able to send the video to that audio-capable device, and the OS will demultiplex out the audio and just send the audio, which is a really neat feature for folks who are wanting to listen to like music videos and things like that. Adding a custom file or stream format. So I want to explain a little bit how this works. So in this case, we have this object called a media stream source. And the application creates one of these things and is responsible for retrieving the content. You can do that using background downloader. You can do that using XHR, HTTP client. You can do it using sockets. However you want to get that content, it's the app's responsibility to get it. Once you get it, you then parse it. So if it's a custom format, let's just say like MKV or even FLAC or something Windows doesn't support natively. If you have a parser that knows how to parse this format, you get a random access stream. You open up that random access stream asynchronously. You parse the header. You get the audio and the video data out, the elementary streams from that, and you feed it into the media stream source. The media stream source attaches to the audio or the video tag or the media element. And then it just plays. So your app is responsible for streaming the content however you like, getting the audio and video elementary samples out, and just pumping it into this media stream source. I mentioned Silverlight. If those of you have done Silverlight development, this was available as part of Silverlight, and we've modified it for WinRT. And it also supports protected content as well as clear content. You can even do uncompressed or compressed samples. So if you want to do your own decoding inside of your application, hoping you're doing that using some sort of hardware acceleration, but you have tremendous power with this API. So this is what it looks like. You define, in this case, what the audio looks like, how many channels it has, what the bit rate is, what's the sampling rate, the duration. You create a media stream source, and you attach that description for what the media looks like to the media stream source. Then there's a whole slew of events that you listen to. For brevity, I'm going to show what it looks like to actually handle the sample requested, which fires every time we need more samples, and expect the application to just hand those samples into the stream source. We're going to go ahead and register for this event handler, and at the bottom you see how easy it is to take that media stream source that you created and just attach it to the audio tag. The implementation of the sample requested handler, this is where sort of magic happens, and unless I have 15 slides, I can't really show you the details. But just imagine you have a custom parser, and you have this object called myCustomFormatParser, and it takes in a random access stream, and you give out an input stream. So you get the random access stream, which is the file. You asynchronously open that, and you read it, and you parse out, and you find the audio data and the video data, and you expose it out as an input stream. And then you take that input stream and you create a media sample with it, and you fire off that media sample. So it's really straightforward. Okay? So again, showed you a little demo of what some of these things looked like. I didn't show you a demo of the media stream source. We walked through sort of deconstructing what those things look like inside of your application. And as a quick overview, set the MS Audio category in your application. If you're not doing it now, then users are probably not having the best experience of your app when they're using it with other applications in the background. And handle the media button events using system media transport controls. At minimum, pause and play. Because when users go to the lock screen or they're not inside of your application and they want to be able to control music playback, this is the way that you do that. It's really straightforward. We've done a lot of work to make it easier for you. And when you're downloading these playlists, set the priority to high. Use background downloader. The OS handles all of the power optimizations and whatnot for you. Streaming to Xbox 360, Xbox One, and a slew of all sorts of other devices, TVs and audio receivers, is really easy to do. So a couple lines of code. Make sure that you complete that experience so that users, when they're playing your music or video in your applications, are able to stream it across. And if you have custom requirements for doing streaming, use Media Stream Source. Just like the background downloader, if you're using Media Stream Source and you're using the network, we make sure that the network doesn't go down on you. So you can continue to stream in the background and not end up hitting those issues where, while in connected standby, you're unable to access the network and stream those tracks. All right, let's check out a simple video demo. See, users need to be able to pause in the background. So we're going to go ahead and open up a sample application. And by the way, all of these things are documented in MSDN, so don't scramble to write it down. It's very simple to search and find these and get code samples that you can go run, such as this one. So this is just a simple, all of these samples, by the way, and everything I'm going to show you are all using the media element with XAML at this moment. So we're going to go ahead and open up this movie. And one of the things that you should notice now in the bottom here is transport controls. So historically, you've had to do all the transport controls custom yourself. You've had to create the buttons, you've had to style those buttons, you've had to listen for the events, you've had to implement those events, so it's a tremendous amount of work. Whereas on the video tag, you could just say controls and get them for free. So with Media Element, you get them for free now if you specify this attribute. But what's really cool about it is you get all kinds of controls that do all the stuff that's really hard historically in the application. So like we have black bars here. Well, let's go ahead and just zoom that and get rid of those black bars. For those of you who've done this yourself, if you're, or even full, right, so first I did full screen and then I did zoom. If your math is off by 1 pixel, you're not getting hardware acceleration, right? Like you have to shut all your UI down and hide it, and make sure that the screen doesn't shut off when someone is watching your video by setting a display request. There's all of this work that you've had to do in your app, hundreds of lines of code in order to just make sure that the video experience is great. If you add one line, which I'll show you, to the markup, you get all of that for free. So that's really cool. And like you would expect to be able to do, you should be able to go ahead and stream to Xbox as well. And have full control, like right within your application. You know, as I mentioned, like these transport controls just turn into the remote control for your device. So you can seek around, you can change the volume, all these things that you'd expect to be able to do. If I can hit it there. So let's go through what that looks like. It's that easy. One line to your markup, or you can set it using code if you like dynamically. So it's no longer necessary. Still possible, right? A lot of you want to do custom styling on your controls. You want to brand them. Keep doing those things if that's something that's important to you, right? But for those of you who just want to do very simple video playback, you can get all of these things for free. And get all the power optimizations that we're going to walk through. So before, in 8.1, again, you had to define all of these buttons. You had to implement the handlers for these buttons when you're playing. One thing that we've noticed, and I'm sure some of you have noticed when you're watching a video, or sometimes if you're reading and the screen shuts off after 2 minutes, you need to set a display request in your application in order to make sure that the screen doesn't shut off. So you get a display request, and when you stop the video, you release it. If you use those default controls, that's all done for you. So that one line, you get display request for free. And you get the implementation of all of these handlers. Full screen, again, so we do various levels of performance optimizations when you're playing video. So while video gets full hardware acceleration, even if it's not full screen, if it's just windowed, the GPU is offloading all of the decoding of those frames. When there's other UI on the screen, the compositor can't go into a more performant mode. So there's all sorts of things that we can do from the renderer all the way up to the compositor when the pixels are painted on the screen. And if you in Windows 8 or Windows 8, you had to like say, hey, I want to go, if someone wanted to go full screen, you had to do the stretch operation where you said, okay, I want to change the width to the width of the screen and the height to the height of the screen. And you had to hide all of the UI that might be overlaid. So if your transport controls were there, you hide them off of the screen. If you didn't hide the UI controls, or if you were even off by 1 pixel, then you lost some of the performance gain because the compositor had to show what was going on in that 1 pixel. So you lose or you simplify your app dramatically just by using that default control. But we've also, for those of you who still want to brand your controls and do custom controls, we've made it way easier to go full screen. We just add a property on the video player, which moves everything out of the way for you, hides your controls, and make sure that you get the best possible performance and battery life. So if you're doing all of the math yourself to try to figure out how to stretch out your video, replace that with is window full. Or is full window, rather. I'm sort of re-emphasizing here that you get all this for free if you set our transport controls enabled. But if you want to zoom, right, now that you each have this cool little small tablet, when you're watching video on these things and it has black bars, it gets squished quite a bit, right? And so really think about developing your app for small screen tablets. So that means things like make sure that your button hit size follows the right guidelines, but also that you implement zoom in your app so that you can zoom those out. And again, you get that for free with the default controls, but you can also simply stretch it using uniform to fill. So you just wire that up to your button and it'll stretch it out for you automatically. Remove those bars and keep the aspect ratio the same. The same is true for playback control. So what you see in each of these samples is it really is a mirror of what I showed you in JavaScript earlier. This is just what the C# code looks like in order to do that and what the XAML markup looks like. So I'm not going to talk about this anymore, but it's an identical version of what you saw before, except for video. Now, different apps have different intentions in terms of the experience. And so if you have a video application and someone moves it to the background, it may be that you don't want to pause it, you just want to mute it. Or maybe you do want to pause it. It all really depends on the type of application that you're building and what you think your users want to experience. But if you're building a video and you want it to pause in the background, or you want it to behave well, I showed the demo of the music app playing, and then I brought up the Xbox video application, and you automatically heard the music pause. And then when you brought the music app to the front, the music played and the video paused. This is an experience that users tend to want in their applications. And so setting foreground-only media on your video has that effect in that other applications that are background audio, Windows will do the right thing in terms of making sure that the audio comes out at the right levels. But also, if you want to pause, then if you set foreground-only media, you're guaranteed that the sound level, so the sound level property, when you listen to that event and it fires, you're guaranteed that it will only say mute when your app's in the background. Right? So this is the way to go, oh, I know my app's in the background now, I can go ahead and pause my video. So here's an example of what a user sees when you set the property in the background downloader for unconstrained download. So if your users in your app have an ability to download really large files and you want it to download as quickly as possible, or you want to give them the option, then you simply set this property and this is what they see. The system takes care of putting a banner up there and asking the user, do you want to download this full tilt, or do you not want to download it full tilt and conserve your battery? So if they choose allow background downloading, then it downloads as fast as possible. Even when the machine idles down, it doesn't restrict how quickly the background happens. And so this is what that looks like. I showed you earlier what a background transfer looks like. It's just the same, except instead of setting the high property, in this case, you actually go through and set that you want it to be unrestricted. And you can add as many operations as you like. So if there's a whole bunch of files that a user wants to download, you simply just add all those different operations. And then the user will be prompted once for downloading them unconstrained. So the Xbox video application implements this now. So when you're downloading TV episodes or movie episodes in the background, they'll go as fast as possible. Again, this is exactly the same, except just using a different language here. To stream, it's just as easy in C# or C++ for that matter as it is in JavaScript. This is also the same. So adding custom file or stream formats, if your language of choice is C++ or C# or JavaScript, implementing this looks mostly identical across the board. Okay, so use our transport controls enabled. You get a whole bunch of stuff for free. If it isn't important to you to style your buttons, we find that most applications would really rather not have to do that work, so we've made it a lot easier. And you get the best performance by using those. I shared some details about if you do want to build custom controls, how you can use the new affordances in order to get the best performance in terms of stretching it out full screen or in terms of how you can zoom those applications. Listen to the sound level changed events in order to know whether you should pause your video in the background in conjunction with setting foreground only media on your media element. So we talked about video performance just a little bit, so I want to highlight some key things. There's been some confusion in the past whereby folks thought that the only time that you get hardware acceleration of your video is if it's full screen. That's not true. So you get full hardware acceleration of your video decoding, whether it's a tiny little square or whether it's full screen across the page. And it's pretty phenomenal, the battery savings that you get just for free, whether you're using a simple video tag or whatever. So any of the default decoders that you can use in the system, so that's VC1, MPEG-2, H.264, all of these are hardware accelerated. You do get best performance when you are in full screen, however, because the compositor gets to go in the special mode where it knows that, oh, I'm just rendering video, so I can shut down a whole bunch of logic that I otherwise would need to do. So making it possible for users to put your videos into full screen is really important. And when you're writing all the code and you want to populate the source attribute on your media element, do that as late as you possibly can. So lazy load that source, because otherwise we pull in a whole bunch of code and start running some things in the background. So the later that you can actually populate that, the more performant your app is going to be. And if you control the service on the other side where users are downloading it, and your application has the ability to communicate with that service, you can further optimize the performance by making sure that the resolution of the video that you're sending them matches their screen. So you can ask Windows, what's the resolution of the screen, and have that intelligence when you actually go and download a video. Because otherwise, we're having to do some conversions real time in there, and you get to avoid doing that altogether. It isn't a make or break deal, but it's one of those things that if you really want to squeeze everything that you possibly can out of that lemon, then this is the way that you do it. For small screen tablets, there's some guidelines that are posted on MSDN about touch targets. This becomes really important now that we have high-density screens and we have these really small screens. So make sure that your touch targets for the screen size that you're on are adjusted appropriately. Otherwise, users are going to hunt around and try to hit that button, and they're not going to be able to hit it, and it's a really sort of puzzling and frustrating experience. So look at those guidelines and make sure that your app uses them for the transport controls. Support Zoom to remove the letterbox on videos. Again, this is really important for small screen tablets. Otherwise, you end up seeing this small little script. For any of you who've tried to watch a video that isn't strictly 16:9 on your phone, you can kind of see that little tiny strip, and it improves the user experience to be able to get rid of that. Consider whether full screen by default is the right thing to do in your application when you're running on a small screen video, and that the screen, it's displayed in landscape mode and locked. at that point. So when users are sort of switching around, they don't end up with some tiny little square in the middle. So these are things that you can do to further think about these small screen tablets and optimize the experience for them. Okay, so I'm going to show you a demo. Pause. Let's switch. Okay. So we're going to look at our friend Big Buck Bunny. And this is a website, so I just want to sort of emphasize here that this new work that we've done for your, if you have an app, so in this case, we have a Big Buck Bunny app that's installed on our Xbox One. And I also have a Big Buck Bunny website that uses HTML5, audio and video technologies, and that could be media, that could be MSE, EME that I mentioned before. So this works for protected content as well as clear content in the browser and in your application, whether you're using HTML5 or whether you're using C++ or C# to develop your application. So I have a Big Buck Bunny app here, and I have my website, and I want to be able to watch this video. So I'm going to go ahead and play Big Buck Bunny, and just like in an application, I'm going to swipe over, and I'm going to choose Xbox One. And I would expect my Big Buck Bunny application to launch automatically without having to do anything and start playing. So this is just a sort of very simple sample example of what could happen here. And again, you have full control to pause and play. So let's take a look at sort of what's going on there. So I have, just here's a very simple markup here of what this Big Buck Bunny website looks like. And what you'll notice is that we have this new attribute that we call Play to Preferred Source URI. So even if you specify a source on the video, if you provide a preferred source and you express, we'll walk through the details of this in a moment here, but you express a custom scheme that you register. We call these protocol handlers. So you say, hey, I have this, instead of http:// you'd say MS-Play2 app, whatever the name of your app is. And your corresponding application on Xbox One registers to handle this, and this is how we're able to discover that that app is on the Xbox One, and we're able to launch it. So let's see what happens when we remove this, just to kind of underscore what that distinguished experience is. So if I remove that, and what I'm left with is just the source right here, I would expect that when I reload, and I play, because I'm not specifying what that preferred source is, then the default app that handles video on Xbox One should be the thing to play it. So let's go ahead and see. And in that case, it's the Xbox Video application. So when I choose Xbox One, it should just play full screen in the Xbox Video app. So that's how you distinguish inside of your application. It's really that easy. You just specify what the preferred source is, and I'll walk you through how to register it. The same is true for apps. So if I swipe over here and I look at the sample application that's Big Buck Bunny. So again, I showed you my Big Buck Bunny website. Now I'm going to show you my Big Buck Bunny app. When I swipe over and I choose Xbox One, it should launch the Big Buck Bunny app because this is the Big Buck Bunny app on this side. So there's your demo. And I'm going to go ahead and pause Big Buck Bunny, and in this case you can see that this application provides the thumbnail, it provides all the details so that I can do full control back and forth. So let's deconstruct what's happening there. So better together with Xbox. So as I mentioned, it works for both apps and for sites, and it works for protected content. Because what's happening is you're passing as part of that preferred source URI, you're encoding whatever you want into that string. So it's a way to pass parameters to your corresponding app on Xbox One. For example, you might say the media ID is 12345, and then your application on Xbox One just goes and streams it directly from the internet using those variables that you've encoded into the URI and sent over to it. So it's very simple. It's optimized for battery performance. You can shut your PC off and this thing keeps playing. You have full control with Kinect. You can say Xbox pause. You can use the gamepad. You can open the Smart Glass application and pause it and control it. So think of the PC, in this case, my tablet, as just another controller, as another way to open up that application. Now the app, in the devices charm, if I'm in your app, if I'm in Big Buck Bunny, and I swipe open the devices charm, the only time if it's a protected app that has premium content in it, the only time Xbox One is going to show in the devices charm is if my app is installed on Xbox One. So it's a form of application discovery. And when you tap it, it launches your application rather than using a generic media player to play it. So you have 100% control of what's going on. And just like in DRM-free, clear scenarios that I showed you before using Xbox One, streaming to the Xbox Music app or the video app on Xbox, you have full control with transport controls and you get all those for free. So when you wire them up, you simply are able to interact with your transport controls the same way that you always would. You can implement the system media transport controls and allow people to control them in that way. So it's a really powerful experience. The transition's really fast, as you saw. It opens your application really quickly. Stream anything that you want. Controls work. It's fast. It's exactly the way that we think it should work. So in your Xbox One app, this is how you express what your protocol is. So you implement or you express a protocol handler. And so in this case, you use MS-Play2 app, which is, you have to use that, MS-Play2 app hyphen, and then use whatever app name you would like there. You can register as many protocol handlers as you like, so you're not restricted to just one, just like on Windows 8.1 applications. So once you've registered that handler, which in this case, just to sort of emphasize, is MS-Play2 app, my app, then in your preferred URI, that's what you use as the scheme instead of HTTP. And then you encode whatever details that you like inside of that string. And this is how we do the one-to-one tying, right? So the application manifest registers and says, this is how I can be launched. In your application, you specify the preferred URI with that scheme in it so that we know how to launch it. And then in your app, by the way, I just want to underscore here, this is the only thing you need to do in your Windows 8.1 app. It's really that simple. There isn't a whole bunch of code that you need to write. You just need to specify the preferred URI. In the Xbox One app contract, we have the target side of Play2, and we call that a Play2 receiver. So you create this Play2 receiver, and think about it like a state machine. So the Play2 receiver object knows how to get commands from the home network. And this would be from your other tablets and PCs that are on the network. So it gets commands like play and pause, and here's the new source item that I want you to play. Very, very simple in terms of media transport controls. So this Play2 receiver object receives these commands. So I might get a play received, or a stop received, or a pause received, or a skip received. This object then registers for, in this case, the video tag. So I have a video tag and I have a Play2 receiver, and when play received is received on my Play2 receiver, I just initiate play on my, it's a one-to-one mapping. Play received, play. Pause received, pause. It's very simple. So you get commands on the network, you translate that command onto your audio or video tag or your media element, and then you update the state to the network by notifying. So there's 3 sets of events that you register for. One on the Play2 receiver to know what the command is. You know how to program the media element, and then you need to know the state of the media element. So if it's playing, you then notify the network that it's in a playing state so that the UI on the tablet can update in those transport controls. Right? So here's a quick overview of sort of what that looks like. Here we subscribe to the events on the Play2 receiver. In this case, we're going to look for when we were told to play and when we were told that we have a new source item. that should be set. And I want to know when the video player, the video tag in this case, is actually in a playing state. So as you can imagine, the play request handler is super simple. As soon as I'm told to play, I'm going to initiate play on the video tag. Source request, in this case, what I'm doing here is when I'm told that I have a new source item, I'm going to go look to see if it actually has that Play2 app specified as part of the URI. And if it does, I know that I actually need to do something with my app here. So I'm going to go ahead and just simply parse that, look for the Play2 app, and then if it's there, I'm going to extract out the information that I've encoded as part of that URI, and I'm going to use it to start my streaming. That might be initializing Play Ready, talking to my service, starting to stream that video down and play it, just like I would if the user used the UI and the gamepad on your Xbox One application directly. If the MS Play2 app isn't there, then you simply set the source the way that you normally would generally, and the default application that handles playing video would go ahead and play that. Okay? And so once I've actually set on the video tag that it should start playing, I want to notify the network so that they know, the controllers on the network know that playing is happening, and you just simply issue a notify playing method on that. And so that's, for example, when you see the transport control show up in the corner, you have that play pause button. By default, it may be it's play. If you notify playing, it'll automatically switch to pause so that the user can then go ahead and hit play. So this just makes sure that the controls are all up to date. Okay, so that's it. We have some related sessions today. So we have building apps that use the camera, which is coming up right after mine. Showing you a ton of really great stuff that we've done in that area. And then later today, we're going to spend a lot of time talking about MPEG Dash and how you build plugin-free, premium AV experiences in the browser. Some related resources here that you can go ahead and take a look at. And really, every session here, if you can, we want to get better. We want to make sure we're giving you the right level of detail. So we appreciate your opinion, and we'd love to hear from you about how you think our sessions are and what we can do better. So with that, I appreciate it. Thank you. If there's any questions, I think we have a little time. There's microphones up here. Oop, sorry. Let me get that back up there.
I have two questions mainly concerning audio. The first one is that my understanding is that offloading of audio decode is no longer permitted. So in that case, the offload would not happen and the system couldn't go into connected standby while playing audio. Is that correct?
That's not correct. So the question was whether or not audio offloading is still permitted.
For decoding.
For decoding. And the answer is yes, it is still permitted. In fact, the system does it for you on your behalf. So for example, if you have a media element that's playing audio, and the audio hardware supports being offloaded, which any machine that supports connected standby would, it would be offloaded into hardware, and even if the machine goes into connected standby, would continue to happen in the audio hardware.
Okay, that's real different.
The question was, is that a flag you have to set in the control? The flags that you set in the control are related to like background audio. So clearly you have to express that your audio can play in the background in order for that to continue working when you're not using the same application. To my recollection, no, but let me go ahead and take a look at that. We can follow up offline for going into maybe a deep dive, some office hours on what you need to do in your application in order to make sure that audio offload happens. But the key takeaway is that audio offload should just happen. You shouldn't have to do anything specific in order to make that happen.
Okay. The second question has to do with unique endpoints. You were talking about the controls coming up automatically, and you could do a stop or a volume control. Does that affect all endpoints on the system, including the external ones like Play2?
So each system media transport control is specific to the application. And the application is responsible for setting the endpoint that they're playing out. So for example, if the app, as opposed to the user, if the application switched the endpoint to, say, like a Bluetooth headset, because you can do that in app code, and the app implements those transport controls, then the audio gets routed the way you would expect.
And that would be true for the buttons, everything?
Yep.
Okay, cool.
Hi.
I got a question. I saw you that the Windows 8.1 apps will better together with Xbox One app. But how to make a Xbox One app? Anything you can share?
So we're not actually having a conversation about how to create Xbox One apps here today. So that's something that the Xbox team will disclose when the Xbox development kits are made available.
So
Yep.
Maybe I can change the subject. Can I make a Xbox One app like we do for the Windows 8 app now today to submit to the store?
So we're not going to have any conversation about what the process is for creating or submitting Xbox One applications to any store.
Okay, cool.
Yep.
Thank you.
You're welcome. Could you ask the question?
I'm a member of the Xbox program.
Okay, great.
So is it going to be for the Xbox program, or is it going to be the new program for Xbox One?
So I'm not on the Xbox team. I'm on the Windows team, and I would really love to be able to answer those questions for you, but I just don't know.
Okay.
Yeah.
Hi. This is about two-screen usages. You touched about this video playback to be a full screen as a default, right? How do we move the media playback to a full screen mode when we are in the extended mode? I mean, is there any application can associate with a particular display when the display configuration changes? Is there any API available for developers?
No. So the question is, when you send your video to the Xbox One and you play it, do you have the ability to command your app on Xbox One and change like resolutions and things like that? Do I understand your question right?
So, I mean, there is a project too. In the Charms, there's a Windows
Yep.
8.1 have the project where you can, connect
Yeah, so
to the
if you're using like
displays.
Miracast, for
Yeah,
example.
displays.
Yeah, and
Yeah.
Miracast is just it's just a mirrored display, and so whatever you do locally, you can do and this is not with Xbox One, but for a Miracast capable device, you can swipe the device's charm and you can choose project. And in that case, you can mirror directly, or you can extend your desktop over and then use it just like a monitor.
Okay. Thanks.
One more question I think we have time for.
I had, two small questions, actually.
Okay.
One is, does UPnP or DLNA still work with all this mechanism?
Yeah, UPnP and DLNA works with all the free content, so DRM free. What we showed, this very last piece that we showed with Xbox One about invoking the corresponding app, that doesn't work on DLNA, but all of the protocol, the details are all UPnP DLNA under the covers. Yeah.
And is there any kiosk mode for apps, for music apps or video apps or whatever?
So I don't know the answer to that. I am wondering whether the new wallpaper, the desktop wallpaper that shows photos, will actually be able to play a video. I don't think so, but off the top of my head, I don't know.
Okay, thanks.
Good questions, though. I'm happy to stay as long as anybody would like, but I don't want to keep others. So I'll just keep answering questions until I get the hook that throws me off the stage. Or folks can just come up and we can have a conversation up here. Thank you, everybody. I appreciate your time.